go to the node. So I'm going to do this one in after this. So firstly, let me finish this application of Faraday's law part. So this Faraday law we discussed when we are doing the galvanic cell, and we are revisiting why, because we are looking at the electrolysis. So what we are looking at here is we try to use this Faraday's law to determine the quantity of reactants or products. The quantity of reactants or products using its mass, volume, or gas. So what we are going to find out? We are going to find out the quantity, right? Right. So we need current or time to use a specific amount of reactants or products, produce a specific amount of products. So what we do here is we try to find out, did I discuss about the equivalence last time, sometime? Did I? 2 weeks ago, maybe? Yeah. So it's related to that. So there we discussed that this Q is proportional to mass. Then this Q is equal to Km. Remember that? Right? So then we define this K to be equivalence, something like that, right? So that we discussed. So now Q is equal to IT is our basic equation to find out the number of charges when in presence of the current, right? So this we know already. And the so-called Faraday's law is to find out the number of electron moles using the Farad, right? So this Q means the total number of charges. This F means the Farad, right? Farad or Faraday constant. Okay. So this we know already. Okay. So now let's jump into this question using that. When a current of 4.5 ampere is passed through a solution for this much of time, 0.2 moles of metal is deposited. What is the amount of the metal that will be deposited if the current of 10 amperes is used for 5 minutes? Okay. Start doing this question. I will take over after. Maybe it's a general question. Okay, take from there. So how much is this number? How much is that number? Huh? Huh? 0 point? And what about this number? This is 0.031? What about this one? 27? Okay. So what is the answer now? So, so, oh, this is not there. So this is given to you, right? So 0.02. So now this you need to calculate. So to calculate this, it's going to be 0.02 divided by 0.027 multiplied with 0.031. Am I right? So make sure these numbers are right. Make sure these numbers are right. So if those numbers are right, this number should be right. Hmm? Because you can see, okay, let me explain that. So we don't know the stoichiometry, right? So suppose this is so this is alpha to lambda to gamma is the stoichiometry because stoichiometry is not given to us, right? So we don't know what metal is that, right? So now what I'm looking at here is my lambda value, right? Yeah. So gamma value is already given to you, right? So now I understand lambda gamma ratio, small math problem, lambda gamma ratio. So for this amount of electron moles, how much is the gamma value? So look at this. So this is the correspondence, right? So if it is 1 mole of electrons, it would be 0.02 divided by 0.027, right? Which is this part. Okay. So I need the M amount for 0.031. So I multiply both sides by 0.031. So which is this one. What is the problem? What is the problem? I don't understand. What is the problem? And like 4.5 like it lasts for 10 minutes and then you get this much of a metal like. Yeah, so you get this much of metals, yes. So the how come? What about the boys? Huh? Not sure? What is the problem, Ananya? Okay, let me explain. Okay, you understand 0.027 number of moles, electron moles are passing through it. So when that is happening, you get 0.02 moles of metal deposition. Now you can see the lambda value and the gamma value, right? You can find the ratio if you want, but we don't need that. So what we are looking at, if you pass 1 mole of electrons, how much is going to be deposited? 0.02 divided by 0.027 number of moles. Agree? It's an equation, right? So now the question says 10 minutes, 10 amperes, 5 minutes, right? So 10 amperes, 5 minutes means we use 0.031 moles of electron moles. We pass this much of electrons. So now for that much of electrons, how much M we produce is the question. So 0.02, this guy, multiplied with 0.031. I don't know what this number, so that's answer. Like they showed us an example like for where is example? Like this is what I thought the question was asking. I thought the question was asking that those 4.5 amps in 10 minutes you can create 0.03 moles from it. That's what I thought. And then I thought the question was asking. You didn't read the question. So metal is depositing. 0.02 amount of metal is depositing due to that amount of current in 10 minutes. Yeah. Okay, what is your confusion now? No, you understand now? Any questions? This is how you have to play with it, right? Similar to what we discussed before. Okay, let's do this question. Everybody. If a solution of copper 2, so now they have specifically given to you copper 2 chloride. So you know copper 2 plus is electrolyzed for 35 minutes using a current this much. Calculate the mass of copper deposited on the cathode and the volume of oxygen gas evolved at SLC. Can you do that? Can be a good one. Can be a good question. What is it? That's what I said. It's a good question. Read the question. It's a copper chloride solution. That means copper chloride aqueous. Aqueous means water is there. So I told you that water plays a big role. Remember, last week I told you in the anode and the cathode, sometimes the water is reacting. The self-ionization of water. I discussed that before. So solution means water is there. That's why the oxygen is evolved. Okay, so let's think about it. I will help you a little bit. So it says at the cathode, what is happening at the cathode? What is happening at the cathode? Cathode means catching electrons, right? So copper 2 plus 2 electrons, you get copper solid. Cathode. What is happening at the anode now? Anode means what? Electrons are provided, yeah? So at the anode, so what you have here? Solution. Solution means water. Aqueous. So you get water. So what would be the reaction? Water gives oxygen. Then you get H plus, I think. Then you get electron here, right? So balance it. So when you balance it, you put 2 here, you put 4 here, you put 4 here, right? So you are balancing stoichiometrically. So now you can see oxygen came out. Yeah. So remember these things. Same thing will come in the exam. Now, okay, that's enough, I think. Now, 35 minutes, 1 ampere. So 35 minutes, 1 ampere means your Q is going to be IT, right? So I is 1, T is 35, but you have to multiply by 60 to get the seconds, right? Yep. How much is that? How much is that quickly? 35 into 60? 2100. Right? Cool. Now, number of moles of electrons. So now this is electrons, right? So number of electron moles now. Number of electron moles, how do you find? Q divided by F. Remember that. Q divided by F. So Q is equal to the amount we have. F is going to be 96,500. Give me that number. 0.22. Number of moles. So now you found that, right? You found that. So calculate the mass. Okay. So now you can see 2 to 1, 2 to 1 ratio, right? So 2 to 1 ratio. So then you can say number of copper uh, amount is equal to half of electron amount. You agree with me? Why? 2 to 1 ratio. 2 to 1, 2 to 1. So that would be half of that. So this could be 0.011 moles. Okay. So now you need to find the mass. So the mass. So mass would be mass of copper is equal to molar mass of copper multiplied with number of copper moles. So molar mass is how much? 63.5 multiplied with 0.011. And when I'm writing it, I write in this way, grams per mole, and multiplied with 0.011 moles. And that is going to be how much? 0.6 grams. Okay, now that is fine. Next one. On the cathode, yeah. So that is fine. That is what we discussed. Now, and the volume of oxygen gas evolved at SLC. Volume of oxygen gas. So now you go to the other anode, the reaction at the anode. So oxygen. So how do you do that one? How do you do that one? Did you do that? Did you do that? Huh? Water? Why do you? Sajid?
I have a very small answer.
Okay, did you get this one?
Yeah, I got that.
Okay, let's see now carefully. Now we found the number of moles, right? We found number of moles. Now we will try to get the overall reaction now. If you think about the overall reaction, what that would be? Overall reaction, what that would be? So you multiply by 2. So it's going to be 2Cu2 plus, then 2H2O, then 2Cu plus 1O2 plus 4H plus. Correct? Correct? That's the overall reaction, right? So now if you look into the overall reaction, you need to locate this. Why? Because that's the number of moles, right? So now we found the copper. Copper amount we have 0.69, yeah? 0.69. So now what is the copper to oxygen ratio? Half. So from there, you get this. So number of oxygen is going to be half of number of copper, which is going to be 0.69 divided by 2. How much is that? 0.345 grams, yeah? Huh? Oh, sorry. Oh, that's a mass. That's a mass. 0.11, 0.011 divided by 2. How much is that? Like that? Yeah. That is the number of moles. Right. So now this much of oxygen moles we produce, right? So now what is the question? Find the volume now. How do you find the volume? Yeah. So we know the molar volume concept. Yeah. So what is the molar volume concept? My friend, Tashani, what is the molar volume concept? Yeah. What is molar volume? Eh? What is molar volume means? What do you know about that? What do you know about molar volume, Pauline? How much is that? 22? I don't know. I don't remember. 24 or 4.8 or something? 24.8. 24.8. What are the conditions? SLC. At SLC, the molar volume is 24.8, right? So what is the unit? Huh? Liters, right? So, yeah. So, okay. Hello, Tashani, look at this. Ayo. What's me? 18-year-old boy in a couple of months' time. So N is equal to M divided by capital M. V divided by Vm. That is the concept. This we mainly use for gas. This we can use for anything. So we find V now, which is going to be N times Vm. Cross multiply. So N is going to be 0.0054 mole multiplied with how much is Vm? Say it again. 24.8 liters per mole. So that should be, I don't know, how much is that? 0.135 liters. So that is nothing but 135 milliliters. Why you say it's small? 135 milliliters is not small. It's like a half of the Coca-Cola. Check my calculation. So that's how to do it. Like check the numbers. Fine. Okay, moving on. What is this? So that's the last question. Take over that one. We are finishing unit 3 now. So this is the last part. It's just calculation. How long it will take for a solution of Ag plus ions to deposit 2.5 grams of silver using current of this? Okay, how long? How long? Okay, time. Quickly do it, Kavya. When is your next Kavya? Next week. So you're going to be number 1, 2, eh? So what rank you need? So last year your buddy Caesaran got number 1 for all his subjects. Yeah, but then also you had to understand your cohort is not a good cohort. He got A plus, like he got like 95 plus A pluses for SACs, which is A plus drags to B plus. It's because of his school. Huh? Yeah. But I don't know, for some reason, Alkira College is pretty good actually. I can say like for almost all the subjects, like I can see that type of a crazy fluctuation. Okay. So how long it will take? Right. Let's see. Ag plus 1 electron Ag. So deposit how much? 2.5 grams. 2.5 grams. So then we will find 2.5 divided by how much is the molar mass of this one? Ag, how much is the molar mass? Look. 107.9. 107.9. So if you divide it, you get number of moles here. So now because of this one-to-one ratio, so we know the number of electron moles is going to be 2.5 divided by 107.9. How much is this number? 0.02321. Okay, so this is the number of moles. Okay. So now we understand Ne, this is equal to Q divided by F, right? Yeah, Q divided by F. So now we understand Q is going to be IT, F, right? So now you can see what you need to find is the time. So you subject time, it's a small math question. So F Ne divided by I. So now F is given to you 96500 coulombs. N is given to you here 0.0231 moles. And then I is given to you here 5 amperes. So now if you do that, T is what? 404. Okay, this much of seconds. So that's not a big deal. Okay, so this is the last part of Unit 3. Yeah, so that's why we have your past papers. So these past papers you have to do by next week. Submit. Okay, now go back. We have to finish this part now. Right. So this is the very last thing we discussed last time. Yeah. So we were discussing about electrolysis in detail, and then how do you get these things done, right? Okay. Okay. So we try to learn rechargeable batteries. Rechargeable batteries. So with your current knowledge, you can understand this concept. Rechargeable battery means what? Discharge and recharge. Both happening. Discharge, when it is discharging, it's a galvanic cell. When it is recharging, it's a electrolysis process. So both are happening. Yeah. So that's the whole concept about it. Okay. So now we'll try to understand. So I break down this so that I can show you charging and discharging process. Since you know electrolysis and galvanic cell concept, first read this one and then we will go through this slowly with all these half reactions. Okay. So let's go with the lead acid accumulator. That's the first rechargeable battery. Some background is there, so just go through it. It's easy for me to go through. Okay. Josh will explain this to me. Go through it, Josh.
Offset accumulator has a long lifespan, a high current flow, and is cheap to produce. Although they are initially more expensive than non-rechargeable batteries due to its durability, it can be cheaper in terms of long-term cost. It consists of a 12-volt battery, typically consisting of 6 2-volt cells. And then cells can be present in components and compartments for improved performance. The cathode consists of lead, and the electrolyte is sulfuric acid with a concentration of approximately 4 amps. And there is a porous plate inside separating the metals.
Okay, so that's the That's the architecture of the battery, right? Yeah. So there are technical issues. We don't need that because that's the improvement of the battery. That engineering part we don't need that. Okay, so explain about the discharging process by Arvind. Discharging process.
The discharging process is like a galvanic cell. So it's a spontaneous reaction. So the anode is Pb and the cathode so it is normal galvanic cell. And it's saying
Huh?
lead lead oxide is reduced to lead flux. And it just deposits on things, and when it is recharged again, it will be deposited back on.
Okay, so you are saying lead Pb becomes Pb2 plus, right?
Okay.
Like that, simply. Then at the cathode, what is happening?
It's
Which one?
it's deposited.
So what is happening? Lead oxide becomes lead sulfate, right? By adding electrons. So, okay. So that we had to know. It's just that's the architecture. So overall process, we don't have to discuss. It's just balance the equation, you get it. Okay. Recharging process. Okay. First of all, why this discharging process is, he mentioned this word, it's a spontaneous reaction, Shashwant. Discharging process, he mentioned, it's a spontaneous reaction. Why he mentioned that word? So whatever this process, discharging process is a spontaneous reaction. Why that process is spontaneous? Huh? Not really. Like oxidation processes are happening everywhere. Not necessarily spontaneous.
We just like being discharged, being vibrations.
Yeah. So why?
Just like
That's how it is. You thought that's how it is? Sujit.
Is it because it doesn't need like energy supply to it?
Yeah. So that reaction is happening without any outside energy supply. That's why it is spontaneous. So it is happening itself. Non-spontaneous means, so recharging process is non-spontaneous. Why? Because we plug that into a external battery to recharge. So there is a input, right? That's why. Okay, Saswant. Yeah. Okay, so explain this discharging process to me, Kavya. I have a question for you. I understand what you're saying. Now, when you have the electrodes, we have a cathode, we have anode. So cathode anode business is there. Also, the polarity business is also there. What do you mean by polarity? The positiveness, negativeness, that's there. So if you take a electrode, so that electrode has a polarity, that electrode has a is defined as cathode anode, right? Right. So now discuss this, including polarity as well.
It's still without, still have them at the black. Anode has oxidation.
Anode has one. Okay. 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 Yeah. So nothing to explain. It's just a reverse of what we had before. Okay. So now the diagram shows you how that is happening, and coating of lead to sulfate and stuff, right? So no need to go through that. So let's go into nickel metal hydride rechargeable cell. Go through that quickly. Go through that quickly. Nickel metal hydride rechargeable cells. Of this one? This one? What do you want to discuss?
How will they have this show? How will the person have this church? Yeah, how does that this show?
Yeah, because these are rechargeable batteries, right? So in the rechargeable battery, you have this like in the container like this, right? So you have a charging port here like that, right? So now suppose, okay, think about galvanic. Galvanic, you have this structure, right? Like this. Why the galvanic has this structure? Because this will give you, this is a non-spontaneous reaction, right? So when you have these two electrodes in here, you are not going to get a, what do you call it? Uh, I forgot the word, like outer circuit current, because it's internally it is leaking. Yeah, that's why we have this separation, right? Otherwise, internal leaks are happening, right? So now for this type of a battery, because it's a rechargeable, you have to have a situation like this, not a situation like this, right? So then in this kind of a situation, this discharge, self-discharge can happen. Slowly. You understand what I'm saying?
Yeah.
That's why.
But I don't get how the increasing temperature affects it.
Huh?
Like increasing temperature.
That becomes worse at high temperatures, because high temperatures, all the chemical reactions are triggering.
Or like kinetic energy.
Like that.
Yeah.
Yeah. So superficially we can think in that way, but it's more sophisticated. When the temperature is high, most reactions triggers, right? Yeah. Okay, so this is in general, right? Okay. So go with the lithium batteries now. Go with the lithium batteries, guys. From the beginning.
Iron batteries, like batteries have like better performance.
Has better performance. Okay.
The reason why they have better performance is that this is how they shelf life and a higher energy density.
Cell life. Okay. And
Higher.
higher energy density. What do you mean by higher energy density? Yeah, something like that. More energy per something, right? Okay.
They have negative graphite, graphite inside. And then
I didn't get the point right. What is it? Hmm? What is it? What is it?
They said impregnated with lithium. Like are they combined or it's like it's not like in there?
So it is not combined. It's just the negative electrode is graphite. So it's like this. It is here. It is here. It is here. It is like that, the structure, engineer thing. Okay. So that's how the electrode is made, the graphite electrode with lithium. So, okay, go for it. Positive electrode is cobalt oxide. Okay, so the positive one is cobalt oxide. Okay. And then this one is what? It's a graphite, right? It's a graphite, yeah. And with lithium, right? So the lithium is coming into what? Coming into the cathode, right? So this is the cathode in this case, right? Correct me? Yeah. Okay. Then
Multiple money, and that there is a, yeah, then coming to lithium ion, so, from the advent time, and lithium ion producing travel through the electrolyte and is able to go through,
yeah.
to get the cathode.
Okay. So the anode cathode reactions are easy to understand, right? And the overall reaction also easy. So that is fine. Now talk about this separator a little bit. So what did you say about the separator?
Solid, I mean,
With permeable to lithium ions.
so, the anode is producing lithium ions, which is traveling through the electrolyte and through the, separator
Mhm.
to get to the cathode where it is like reduced to become lithium or gold.
Okay.
And the function of the separator is to like prevent the electrodes from coming into one with one separating into
Separating two electrodes, yeah. So there will be an exam question, like what is the purpose of this separator? Like we'll discuss that. So you will see in here in the past paper questions also you have that, so you have to do it. Okay, let's talk about the discharging and recharging process. Actually, we discussed, né? We discussed nothing else to discuss in here. Yeah. Okay, so this question we need to do for homework. And this question is a very famous question. So in books, in past papers, you will see this question. Books and past papers. So you better do this one, and I will check that next week. Right. So this part, society energy needs responses. Yeah. So this part you need to read by next week. So we will discuss this part. We will discuss this part by next week, and that's more about the green chemistry and then use in industrials. So, and once after we discuss this part, so this is just questions, and then this part we already done. So it's just this part we need to do next week, and that's the end of the chapter that we will do next week. So that's the end of that. So unit 4 pieces, I will give it to you next week. But you have a lot of questions to finish by next week. So all of these are past papers, and we are starting, organic chemistry part, which probably we will do pretty quickly in 2 weeks' time. So we'll try to finish this organic chemistry part. Most of these things I did in unit 1, I think, and then we have to move to spectroscopy, and then most of the unit 4 stuff are done. Spectroscopy, yeah. So yeah, little more to do. So any questions? Yeah. So okay, so we have a small parent-teacher meeting. Sit down for 5 minutes. Pavnit, sit down for 5 minutes. Eh? Yeah, come back. Okay, so a very quick thing, parents, very quick thing. So I want to discuss the process we are having now. Still, some of the kids are not serious about their work. 5 months to go, right? So before I go into this, I will show you the importance of um, right. So look at this. This is one of the student who did VCE 2024. Yeah, 24. So you can see the multiple choice questions. In chemistry, there are 30 multiple choice questions. You have to definitely cross 25 out of 30. Otherwise, you are not going to go for a good result. That's how the nature. So now you can see this student scored 27 out of 30. So how much he scored in 2024? Having 27 out of 30. He scored 43 row. 43 row. So 27 out of 30 is a very good result, right? But still, that's how it is. So now based on this, now this is for chemistry, right? So chemistry, you get 30 multiple choice questions, right? So I'll show you. Yeah. So I'll show you other exams. So you can see other exams. What is this one? This one, math methods, right? So math method has only 20 MCQs. Math methods, 20 MCQs. Other subjects, 20. Chemistry, physics, 20. Biology, 40. But chemistry, 30 MCQs. So it's a big portion. Big portion. So it is graded out of 120 in chemistry. So 34 MCQs. So short answer out of 90. Now you can see the proportion, one-fourth MCQs, right? So because of this, we have this system, which I'm going to show everybody. Individual results are there, so I can't help. Now, this this is what I see. This is this teacher's portal. So we have done couple of, you can see 24 MCQ tests we have done so far. But these are not that serious questions because these are like, some, previous unit questions as well. So when you go to the results, I get results like this. You can see the failures. I set this to 80% passing mark. 80% passing mark means how much? 80%, 0.8 times 30, 24. So 24 out of 30. So if you score 24 plus, it's a pass. But what is our VC requirement? 25. So it's a fair point here. So now you can see, I gave 45 minutes, 30 questions like in the exam paper, and started this, right? So you can see how kids are performing. You can see only 2 people pass. And some people on the fence, see? And some people are not serious enough of what they're doing as well. So that's why this problem, right? Okay. So now, anyways, this is happening every single week now because we have 5 months to go. So that means 20 weeks. So 20 MCQ papers will be discussed like this. So they have to, rectify these questions as well. Okay. Now that is fine. Right. So then we'll go to our class. Right. So this is our normal class. So they will see their material here. So today we did a paper. So this paper, for example, we have, that is solution. Yeah. So this is the paper. So these questions we did. Now the paper is here, so I will hand over this to them. We didn't grade it, but the solutions already uploaded. If you go through this one, you can see some of the questions they kept blank. Some of the questions they kept blank. Now my problem is next week also they will keep some of the things blank. I feel like with their busy life, they are dragging the things without improving. So when you see they are dragging their things, you will see they are busy. Yes, they are busy with their things, day-to-day things, but there is no improvement. They are busy without improvement. So busyness without an improvement is junk. Why you are going to be busy without an improvement? So, and some people wake up until 2 p.m. without producing any efficiency. So what's the point? So please address that because these things are not in my hand right now. It's 5 months to go. So what I have, you can see exam predictions. So these things I will provide. MCQ training I will provide. Revision, the theory revision I will provide. We have unit 4 to cover, that I will provide. And when it comes to our, not this one, yeah. Our theory note, you can see, let me show you very quickly. Yeah, so this theory part, we finished today. We did a couple of questions and went through these questions. And then we have past paper questions. They have to submit by next week. So if you go through this note, you can see 2022 chemistry paper question, and all the past papers are included here. These are filtered out questions to that topic. They have to do. Some of them, they keep the things blank. Now, the best way to see what they're doing, you can get this document and see whether they have completed it, right? So now if you go to previous lessons, like I'll show you very quickly, in previous lessons as well. So this we did today, these things we did today. Yeah, so this we started today and finished it. You can see after each and every session, I will show you. So all of these are theory. See, these questions, they are homework. So these are the exercises we did. You can see all of these are homework. Okay. So let me show you the past paper thing. Most of the questions we have done, but they have homework to do, especially you can see here. Right? Do all up to this. See, all of these questions are past paper questions. You can see 2012 Vika. So they have to do it. Right? The related theory I have done before. I'll show you. So all of these are questions. See, all of these theory we have done before. This theory we have done before. So the questions are related to that theory. See, all of these theory are done before. So the questions are related to that. So go home and please make sure they have done it. SAC is coming. They might fail otherwise. Because why I'm saying they might fail? Because before they do the SAC, before they do the final exam, I do the papers here. So when I do papers here, and if I say he or she is going to fail, that's the prediction. So before it is happening, I'm telling you. So you can take an opportunity to fix it. So please do that. Yeah. So a lot of things to do. Most of the things they have to do at home, like the homework and stuff. Yeah. And this is not a very hard subject. So this is actually content-wise nothing. But when it comes to exam, you have to properly prepare for exam. Even further math is hard, you know that, when it comes to the exam. Yeah. Yeah. So it's just want to discuss that with you. Yeah. So I invited all the parents, but some parents didn't come, so I can't help with that. But I did my part. Yeah.
Do they have access to these previous papers which you have already done?
Uh,
Can they redo the papers, the old papers which they have done? Which you were showing?
Like if you go here, it's a 17th week, yeah. So if you go here, this is a 16th week. So likewise, those papers are here. You can see exam. See here exam. So those papers are already uploaded, and the physical copy also they have. Like, yeah. So they have, yes. See, week 15, revision chemistry paper 1. You can see all of these things are there. Yeah. So week 13, because week 14 is our Easter break, I think. Yeah, Easter break. So you can see, homework is there. Everything is here. They have access. Yeah. So additional thing is MCQ training every single week, plus past papers we do. So yeah. So they have to compile everything right now. Yeah. Okay. Thank you very much.